Hello and welcome to another episode of Atherosclerosis podcast, the podcast series hosted by the European Atherosclerosis Society Young Fellows. My name is Alexandr Ceasovschih from Grigore Popov University of Medicine and Pharmacy, Iași, Romania, and I will be your host for today's episode. This episode is being recorded right from the heart of the AS Congress in Glasgow. Today's guest is Professor Göran Hansson, a leading Swedish physician and researcher known for his groundbreaking work on cardiovascular disease and inflammation. He's a professor at Karolinska Institutet and a former Secretary General of the Royal Swedish Academy of Sciences, where he also played a key role in the Nobel Prize process. Welcome, Professor Hansson.
Thank you very much, Alexandr.
It is a pleasure to have you here today. On behalf of the AS Young Fellows, I would like to thank you for accepting our invitation.
My privilege.
I only gave a very brief introduction of you to our listeners. So could you please introduce yourself and tell us who is Göran Hansson?
Göran Hansson is a guy who studied medicine, became a physician with the intention of becoming a card-carrying cardiologist, but got sidetracked into research, excited about vascular biology and immunology, and was lucky enough to make some interesting discoveries there, and that kept me on that track ever since. So for the last 40-something years, I've been doing mainly research and matters and issues related to research, such as the Academy of Sciences and the Nobel Prize that you mentioned. And not much came out of my ambitions for clinical cardiology.
Thank you, Professor. Could you please describe a typical day in your life, either research day, and explain to us how do you manage to balance your research with your leadership role?
Well, to be honest, at my ripe age, I'm not heading the division any longer. So I largely work from home, writing and thinking, attend seminars, discussions about research projects and so forth. But I don't sit at the bench at all, to be honest. But don't tell anyone about that.
Could you tell us about your academic journey and what led you to focus on studying atherosclerosis, lipids, lipoproteins, and generally cardiovascular diseases from the epidemiological point of view? And how did your journey start, and which obstacles did you have to overcome?
Well, I had all the possible obstacles, but I can come into them later. When I was in medical school in the 70s, there was really a virtual epidemic in myocardial infarctions. Patients came in with heart attacks every night in the hospital. Many died on the way there, and the mortality was unbelievably high. Those that came alive to the hospital, many of them died during the first week. You couldn't really do much except check for arrhythmias and then try to treat those. Those who survived, many of them had heart failure as a consequence. So it was a huge medical problem and a big challenge. And of course, that attracted me to try to help by working on its causes and try to find ways to do something about it. And the first challenge there, of course, was to find out what is atherosclerosis, that disease that lies behind all these cases of heart attacks and also ischemic strokes. Since then, fortunately, we've seen the incidence go down, but it was a dramatic times, and I think research, not my own personal so much, but generally speaking, science has contributed immensely to the improvements that we have seen.
It's so interesting. Professor, you served on the Nobel Committee of Physiology and Medicine for 17 years, including a term as its chairman. So did you first become involved and how you was involved with the Nobel Committee and what was that path like?
Well, I moved to the Karolinska to take up a chair in cardiovascular research in 1995. couple of years later, I was elected to the Nobel Assembly, the body consisting of professors at Karolinska that make the final decision on the Nobel Prize in Physiology or Medicine. And then the following year, I was elected to the committee and remained on there for many years. To be on the Nobel Committee means a lot of work, but it's a fantastic continuing education for a medical scientist, because you get to learn about and read about some of the best discoveries and some of the best work that has been done in the field. So it's been immensely rewarding.
We are so eagerly looking forward to your keynote lecture tomorrow, titled How to Win the Nobel Prize. Could you give us a brief preview and share a couple of key points you will be discussing?
Well, I'll be careful not to say too much, because then you won't come to my lecture. But, you know, at every scientific conference, there should be how-to sessions about how to sequence DNA or how to run a clinical trial. So I thought for those who are interested in winning the Nobel Prize, there should be a how-to session for them as well. So here it comes tomorrow. Stay tuned.
So for our listeners who will not attend to AAC Congress in Glasgow. Okay. Also, do you have any particularly memorable experience from your time on the Nobel Committee that you'd like willing to share with our audience?
Many, not least all the telephone calls I made to tell scientists that they won the Nobel Prize. I did it first for 9 years as secretary of the Nobel Committee for Medicine, and then for another 7 years as Secretary General of the Royal Academy of Sciences that awards the prizes in physics and chemistry and the economics prize. So I have many fun memories. Which one should I mention? Not one I plan to talk about tomorrow, of course. There's been all kinds of reactions from those who you can feel that they have expected the call. They are so well formulated in their replies that you cannot be so balanced in your comment, where if it's say 4 o'clock in the morning, if it's an American. So you just feel that they must have expected this and written down what they were about to say. To those who are totally astonished and had no idea this would happen. And I remember one who was really off balance, because how could she fit this into her schedule? She said she had to fix breakfast for the kids, and she had put the washing machine on, and she had to drive the kids to school, and then there was a lab meeting in the morning. So there was no way she could handle this button of that. I had to tell her to sit down with a cup of coffee and think through what she was going to say when the media would start to call in an hour, because as I had to apologize to her, we had destroyed her day. But she forgave us when she came to receive the Nobel Prize a couple of months later.
Professor, your research has revolutionized the way we understand atherosclerosis, transforming from a simple lipid storage disease to an inflammatory and immune-driven process. Can you take us back to when you first made this connection? What led you to explore this new perspective, and how was it initially received by the scientific community?
Well, I have to take you back to the 1980s, when the discussion in the atherosclerosis community was whether this was as you said, a lipid storage disease or a scar formation in the blood vessels. And I decided to map the cell types in the atherosclerotic lesion, because that was possible by then because of the monoclonal antibody technology, which was brand new at that time. So I used monoclonal antibodies to map the cells of the lesion and found the expected, smooth muscle cells and endothelial cells. We found a large number of macrophages. And what was interesting was that many of them were activated. We used a marker for macrophage activation. And it turned out that there was immense activation on the macrophages and also on the smooth muscle and endothelial cells. And this activation could only come about by a cytokine produced by T cells. So therefore, there must be T cells there as well. And when we looked for them, we found them. And now we had a whole repertoire of cells that drive an immune response. T cells, macrophages, dendritic cells were later on found, B cells. So that showed that this is an immune inflammatory process, an immune response of the kind we call inflammation. And now we understand so much more about it and realize that it's essentially an inflammatory immune response initiated when cholesterol-containing lipoprotein particles accumulate in the artery wall.
Your work highlighted the role of adaptive immunity, especially T cells and cytokines in the development of atherosclerotic plaques. Which immune pathway do you believe are the most promising target for future therapy?
In the short-term perspective, it's innate immunity and macrophage activation. And we've already seen success there with interleukin-1 beta blockers and inhibitors of the inflammasome. In the long-term perspective, I remain optimistic that we can use adaptive immunity because it's so much more specific than innate immunity. You can target it precisely to those particular molecules that you have the response to. Whereas if you block inflammation, innate immunity, you block much more broadly, and therefore you may have more side effects.
What do you think is still the biggest unknown in the immune mechanism behind atherosclerosis that researchers need to solve?
Ways to control the immune response, to stew it from an inflammatory one to an anti-inflammatory one is, I would say, a major challenge. And several investigators are working on it, but there's so much more to do in order to be able to use it clinically. The basics of it are not completely, but to a large extent understood. But how to apply this basic knowledge in medicine, that remains to be figured out.
You've published several papers on PCSK6 and its role in vascular remodeling. Given the current emphasis on PCSK9 in cardiovascular research, do you think other protein convertases such as PCSK6 are being overlooked by the scientific community at the time?
Well, this is a large family of enzymes that have very broad effects. And PCSK6 does entirely different things than PCSK9. It doesn't operate on LDL receptors, but on transforming growth factor beta and possibly von Willebrand factor, AMP, and metalloproteinases. So it's a different type of biology that is modulated by PCSK6. I should, in all fairness, say that I've been collaborating on those studies, but it's other people at our center who are the driving forces, particularly Ljubika Macic and Ulf Edin, who are our lab neighbors.
Can you tell us about some new projects that you are excited about?
Yeah, well, I am very excited about the interface between immunology and metabolism, which we often call immunometabolism. And for several reasons, we see more and more how immune cells and inflammation are involved in metabolic processes. Clearly in atherosclerosis, but also in obesity and the metabolic syndrome, which are so prominent as risk factors for developing cardiovascular disease. Also in fatty liver. So there, I think we have a lot to figure out in order to be able to use this. We see therapeutic effects already, signals there in studies of for instance, the anti-obesity, type 2 diabetes medicines, and in many other situations. So I think there is much more to learn there and to use therapeutically. I'm also very interested in another aspect of immunometabolism, namely how metabolites control inflammatory responses. One of them is molecules in the degradation of tryptophan that have anti-inflammatory immunomodulatory effects, and that we are pursuing.
Now that we are coming to our end, we always have a section dedicated to failures, which we call the graveyard of ideas. Most of the time, we only hear success stories of other researchers, which makes some of us questions ourselves. We want all researchers to know that failure is part of the process, so we decided to ask everyone in this series of interviews to contribute an idea to our graveyard of ideas. This could be a story about a grant you were passionate about, but it did not work out, or any kind of failure you faced during your academic journey. So what is your contribution to our graveyard?
Well, I have so many to choose between, so it's hard. But I thought I'd mention restenosis. We and many others were interested in trying to block restenosis after vascular procedures, vascular surgery and catheters and stuff. And it looked very straightforward with the rat model, with a balloon catheter injury in the rat carotid artery. And we found that first that gamma interferon inhibited the process. And we thought this could be used therapeutically, but then, and we're very excited about it and wrote several papers about it. Then we realized that gamma interferon is such a powerful immune activator that it would be detrimental to use it. So fortunately, we stopped in time because it would not have been a good idea to continue along that route. Instead, we identified cyclosporin, the immunosuppressant, as an inhibitor of restenosis. And that, there we got into problems because the drug companies were not interested. They say, here comes a crazy immunologist who thinks he can treat heart disease with cyclosporin, haha. But our American colleagues were much more successful with rapamycin or sirolimus, which is another member of the family of immunosuppressants. And they got it all the way to drug-eluting stents, which had been a partial success, but not at all the success we had expected in the 90s, because we see now they're in stent thrombosis problems and things. So they have their place in the therapeutic armamentarium, but it's not as big as we had expected. And generally speaking, that rat model I mentioned turned out not to be very predictive at all to humans, because in the rat, you scratch a normal artery and you get a scar formation. In man, you scratch a sick artery that has so much pathology there already that the rat model was not very predictive for what's going to happen in humans. So we overestimated the power of the model, and we underestimated the conservatism of the drug companies.
Thank you, Professor. In conclusion, about future perspectives. So inflammation is now recognized as a central factor, not just in atherosclerosis, but also in heart failure, arrhythmias, and even aortic diseases. How do you think this inflammatory paradigm will reshape cardiovascular medicine in whole?
Well, that is a bit hard to say. When it comes to the other conditions you mentioned, I think we are at an early stage, and there's much more to learn about the role of immune mechanisms, including inflammation there. I'm very pleased with the fact that inflammation has taken its role in our understanding of the pathogenesis. It's found its place in the textbooks in cardiology, so to say. But we haven't come very far when it comes to therapy. And there I think we have major challenges ahead. And I think it'll be an interesting future to see how they play out.
Thank you, Professor Hansson, for sharing your time and insights with us. This was an incredible interview. Thank you so much.
Thank you. It was a great pleasure talking to you.
Also, a big thank to all our listeners. This podcast is for you, and we need your feedback to tailor it to our interests. So please don't forget to leave us your impressions and stay tuned. And again, thank you very much, Professor Hansson.
Thank you.